Section 10.3, Simplifying Radical Expressions. All right, so the product rule for radicals states that the nth root of a times the nth root of b is equal to the nth root of a times b. For example, the square root of 5 times the square root of 7 is equal to the square root of 5 times 7, which is the square root of 35. The square root of 11 times the square root of p would be the square root of 11p. The square root of 7 times the square root of 11xyz, multiply and get the square root of 77xyz. All right, example 2, same thing. Even though we've changed the index, as long as the index is the same, we can multiply. So this would equal the cube root of 3 times 12, which is the cube root of 36. All right, the fourth root of 8y times the fourth root of 3r squared, multiply and get the fourth root of 24yr squared. All right, the sixth root of 10m to the fourth times the sixth root of 5m. The index is the same, so that would be the sixth root of 50m to the fifth. And it's m to the fifth because you add those exponents, and this m has an assumed exponent of 1. Oops. All right, the fourth root of 2 times the fifth root of 2. Now this one, I can't do it in the same way because my indices are different. I have a 4 and I have a 5. So for this one, we'll just say it can't be found directly using the product rule. Okay, it can be found, but we just can't find it using the product rule. What you would have to do is rewrite each radical as a fractional exponent and then simplify it that way, but we'll talk about that in a later example. All right, next we have the quotient rules for radical, or the quotient rule for radical. If you have the nth root of a over b, you can separate it and make it the nth root of a over the nth root of b, of course, where b is not equal to 0. All right, so for example, we want to simplify the square root of 16 over 25. So I can separate this and make it the square root of 16 over the square root of 25, and then take the square root of each. So that would equal 4/5. All right, the square root of 7 over 36. I can make this the square root of 7 over the square root of 36. Now the square root of 7, I can't simplify that, so I'll leave that as the square root of 7, but the square root of 36 is 6, so the square root of 7 over 6. All right, the cube root of negative 8 over 15, not 15, sorry, over 8 over 125. All right, I can make this the cube root of negative 8, and it doesn't matter where you put that negative, you can go with the numerator or the denominator, over the cube root of 125. All right, since my root is odd, this will be a real number, and so the cube root of negative 8 is negative 2, and the cube root of 125 is 5, so negative 2/5. Okay, let's see. The cube root of 7 over 216. I can write that as the cube root of 7 over the cube root of 216. I can't simplify the cube root of 7, so I will leave that as the cube root of 7. And the cube root of 216 is 6. All right, the fifth root of x over 32, can write that as the fifth root of x over the fifth root of 32. I can't simplify the fifth root of x, so I will leave that. And then the fifth root of 32 is 2. And let's try one more. The negative cube root of m to the 6 over 125. All right, so carry that negative over, then it'll be the cube root of m to the 6 over the cube root of 125. And again, carry that negative over. The cube root of m to the 6 would be m to the second, and the cube root of 125 is 5. So negative m squared over 5. All right, so recall that the n is called the index and the portion that is under the radical is called the radicand. And then let's look at the conditions for a simplified radical. All right, so the radicand can have no factor raised to a power greater than or equal to the index. All right, the radicand has no fractions. No denominator contains a radical. And if you do have a radical in the denominator, you will have to rationalize the denominator. And then exponents in the radicand and the index of the radical have greatest common factor of 1. All right, so these are the conditions that must be met in order for a radical to be in simplified form, or the simplest form. All right, so let's see if these are simplified. The square root of 22 does meet all of the conditions. So if we look back, the radicand has no factor raised to a power greater than or equal to the index, and that is true because 22 is the same as 2 times 11 if you want to break it down. And each exponent is 1. And so that exponent is not greater than the index, which is 2. It's an understood 2. All right, if you look at the second condition, the radicand has no fractions, and it does not. The denominator does not contain a radical. There's no denominator there. And then the exponents in the radicand and the index of the radical have greatest common factor 1, and the greatest common factor of this understood 2 and 1 would be 1. So that is in simplified form. So we will say, yes. All right, the next one, the square root of 15xy. If you wanted to break it down, you could write it as 3 times 5xy. So yes, again, that is in simplest form. The cube root of 18 is the same as 2 times 3 squared, or 2 to the first times 3 squared, and that does meet all of the conditions, so we will say yes. All right, and then part D, again, we've met all the conditions. The exponent is not larger than the index. You don't contain any fractions. It doesn't contain any fractions, and you don't have any radicals in the denominator. So again, yes, this is in simplest form. All right, let's look at some that may not be in simplest form. All right, the square root of 28, I can write that as the square root of 4 times 7, all right? Or the square root of 2 squared times 7. So here I've broken one of the conditions because the exponent and the index are the same. I can take that square root. So I would simplify this and now write it as 2 square root of 7. Now this is in simplest form, but this is not. Okay. Same thing here. I can write this as the cube root of 3 over the cube root of 5. Well, I've broken one of the conditions because I have a radical in the denominator. So I would need to rationalize that. I'd rationalize it by multiplying the cube root, by multiplying by the cube root of 5 squared. And so that would equal the cube root of 75 over 5. So this one is not simplified, but I just showed you how you would simplify it. Part G, of course, this is not in simplest form because we have a radical in the denominator. So we would need to rationalize this, 7 over the square root of 7, and I would multiply it by the square root of 7 over the square root of 7. So this is equal to 7 square root of 7 over 7. So this one is not simplified, but I just showed you how you would simplify it. And then part H, again, this is not in simplest form because we have an exponent that is larger than the index. So that is the same as r to the 4th. So that one is not simplified, but I just showed you how you would simplify it.